Cortana, what do I have to do this afternoon?
I found one event for this afternoon. At 15 o'clock, you have to moderate the webinar, Unleashing AI for Business, Society and the Future with Microsoft.
Thank you so much. What about next? Anything else?
At 17 o'clock, I will switch off. Thanks God it's Friday and I do not have to interact with you until Monday. Have a good weekend, Salvatore. Bye-bye.
Artificial intelligence. Yes, unleashing AI for business, society, and the future. This is not really the answer I expected from Cortana, and probably by the time she will tell me that, she would be fired as an assistant. But the world of work in which we are entering, the companies that our youth will start up will have to deal with artificial intelligence. So we are going to unleash artificial intelligence today, and we are very grateful to Microsoft. Why? Because Microsoft is a long-term partner of Junior Achievement in Europe, and this year is also a signatory partner of one of our main flagship event, the European Enterprise Challenge that we are hosting virtually in Greece. What does it mean being a signatory award partner? Well, for this year, we are going to have Microsoft selecting the best forward-looking technology-driven concept with a strong business potential that among the 18 startups that we have selected as national finalists in their own countries will be selected because they are the ones really that are embracing technology and they are really the best in looking forward. So there will be a cash prize, but as well there will be mentoring opportunities and a lot of career developments that that will be provided to the young entrepreneurs who win the signatory award. So we are in a virtual space. We definitely are with many webinars those days, but this is going to be a very interesting one. I can tell you. Why are you staying in a webinars on a Friday afternoon? We're about to enter into summer because probably you are ready looking at the future. And in the future, we will not be alone. We will be surrounded by artificial intelligence. I have the pleasure, it is an absolute pleasure for me to be with Gabrielle Davelaar and Eleni Santorinaiou, both of them data and AI specialists at Microsoft. As I said, we have strong partnerships, and obviously when it comes to AI, we refer to them. But also let me thank Sylvie Lafarge, Kate Margaret Barnes, and Jeff Bullingwell at Microsoft for all the support that they have been providing it, not only for the webinars, not only for the GEA Europe Enterprise Challenges, virtualizations, all the support that they are giving us to move us into the future. So without further ado, because of course, when we talk about AI, we talk about data, we talk about innovation, we talk about general AI, we talk about specific AI. Where do we stand in this moment? Is AI going to replace jobs? We don't know. We'll see. We'll ask. Who are we going to ask? Gabrielle Davelaar with us. Gabrielle, are you there?
I am here. Thank you very much, Salvatore. Everybody, a warm welcome to this webinar about AI, and in that sense also how it is largely extending to the influence on society. Eleni and I are going to talk today about the potential of AI, the kind of things you want to think about when we are developing AI, and most importantly, what kind of impact it can bring to society. So let's start first with the agenda. We have an agenda that kind of looks into a very high level 102 type of question you as an entrepreneur should be asking in the end when you're developing such a system. So we'll start first with something about AI for good. What does it mean? What does it mean to be doing something good with AI? Then also something, what is the bad side on it? What are the kind of things that you can also see and achieve with AI, artificial intelligence, and that you would like to avoid? Then we will move into AI for all. What does that mean? Lastly, before we're going to start with the demo and quiz as something as an activity within the webinar, we're going to talk about the cooperation between AI and data. Then we'll follow by a demo and a quiz where you actively can answer a question and we'll see what will happen. And it all has to do with this really kind of question about how AI responds to society and what you can expect or what not expect and what type of questions you should be asking in there. Then we will go into what type of biases based on the quiz that we did and how to overcome them. And then lastly, into the really 400 level that you will see currently happening in the AI community, pretty tough. We'll talk about this hottest debate. So let's go to the first slide, AI for good. For this, we have actually a small video clip to let you think about what AI can do for the good. Eleni, I don't hear the sound. Are you able to?
Yep, if we can just, I think when sharing the screen, if you can just click on this little tick about sharing also the sound when you stop sharing and resharing.
Powered by data. Those data remain.
There we are. The nice things of being live.
Is the symbiotic relationship between the human and machine that brings the magic of AI to medicine in a meaningful way.
Now we have the tools to make a huge difference to human life. Cancer research is increasingly powered by data. Those data remain siloed across institutions.
We're creating a data ecosystem that allows people to share data and making sure that we're doing that in a way that still maintains the privacy of the patients.
With the power of AI, we can go after the unknown, and I can guarantee that we'll find something that nobody expected.
Silent infant death syndrome scares every mother and father, and it is a problem we have to change. The collaboration with Microsoft, AI for Health, will help to start this next step of our discovery. Our data show very convincingly clear correlation between smoking and SIDS, and just changing behavior can save children's lives. You cannot measure the benefit of that.
It's a sad day when the patient comes in and I can't impact them.
Through AI for Health, we will be building an AI solution that can autonomously diagnose diabetic retinopathy.
With the portable camera, I can take healthcare to the patients who would not be able to come to us. I want you to look right here.
Going forward, we can address the 500 million patients that are out there and disrupt this disease. AI for Health and IRIS together can have that impact.
Today, there are 200,000 leprosy patients diagnosed every year. If you catch it in the stage of a skin lesion, you can cure the person. We are teaching an AI algorithm to recognize leprosy in an image of a skin lesion.
With AI, we can help patients help themselves to get to the right experts at the right time. If you can help a child to not lose their fingers, that means everything.
Innovation comes from bringing different perspectives together. And what an amazing partnership this is for all of us.
When you see that you can make a big impact on somebody's life, that's the greatest thing ever.
We can help eliminate the oldest disease known to man and make history. That's how we want to contribute to the world.
Amazing.
All right. So this is the good side. Now you may wonder the bad side. Unfortunately, we see this also happening quite a lot. And I think if we look into the recent events, there are quite some things that we can relate to. For example, what we know is that when we're talking about facial recognition, it's still very hard for a facial recognition algorithm to recognize Black people. And this is a very hard problem to crack. And then also a thing is that these type of algorithms can be used for the bad things. So in the recent events that we have seen is that not only Microsoft, but also AWS and Google actually said out loud, we're not going to sell our facial recognition to the police in terms of using for the recent protests that have been going on throughout the world. And this is something that you think of. What is the impact of my algorithm? What am I doing? Am I doing something good, or am I doing something that could actually be not of a benefit for society? Next slide, please. And it's interesting to see this, right? If we look, for example, at the European Union, they also recognize this threat. And they actually said it's very important to have some kind of regulation in place that will check for those algorithms that are doing more bad than good for the society. And this is actually in the guidelines, the ethic guidelines for trustworthy AI. And what it says, and I think this is quite crucial in there, trustworthy AI will be our North Star, since human beings will only be able to confidently and fully reap the benefits of AI if they can trust the technology. And for trust, it means that it has to be good. It has to be for good. So
well,
next
Gabrielle,
slide.
I still trust Cortana after what she said at the beginning of the meeting. Yeah?
Yes, right? You can do
I
that.
still trust her. I don't know if she trusts me, but I still trust her.
Okay, so next slide. So when we're talking about AI, right? I think it's important to think about AI in society. We are not talking only about the technology, and actually we're talking more, and we should talk more about the social impact it has. For example, liability. Who's to blame when something goes wrong? For example, if I go in my Tesla or in another autonomous driving car, and I'm driving and I'm hitting someone, who's to blame? Am I the person, or is that the car manufacturer? Privacy. What is considered as personal data? And this is a very difficult question, because at first you might say, well, it's my name, it's my phone number, but what if it can lead back to me as something? Is that then personal? And then also ethics, equal treatment. What does that mean? And these three pillars are crucial for something that Eleni will tell about in the next slide. So over to you, Eleni.
Cool. Thanks, Gabrielle. So basically, we say that AI is for all. But does this include all the principles? There are some myths that we need to bust, basically. So if we want to design an AI system, there is the myth that you need a computer science degree. So we have examples of people that, for example, a person in US with English literature as a major decided to change careers to work as a software engineer at Kiva. Kiva is an organization that does small loans in developing countries, where basically the algorithms used in order to identify the users of this platform were trained only with pictures of white people. So these were not accurate. So she introduced a much more diverse data set, and the Kiva platform was accessible to people and users that really were using the platform. The other myth is that you need big data in order to do AI. So you will see at the demo that Gabrielle will show you later that in order for an algorithm to do, for example, custom vision and identify which people in the pictures are wearing a mask, you need some dozens of pictures. Definitely not the variety, the velocity, and the volume of big data. So this myth is busted as well, depending a lot on the use case. The next myth that we are going to bust is that we need expensive computational power. That is also a myth because in many cases you won't be able to use, you might be not able to use your laptop to train a complex model, but you can use cloud, and that's why cloud exists. You can use ready models with a simple user interface in order to train them, and you can rent resources on cloud for as long as you need them to run a model. And finally, you need to study advanced math before designing such system. Now, there is a very interesting book by Paul Lockhart that describes basically the nightmare of a musician. And in this book, in this nightmare, the musician lives in a world where people need to study the theory of music until they're 20 years old, write the notes in sheet, and try to understand the theory without ever being able to sing until they reach the age of 20. And fortunately, this is a dystopian world and this does not exist, but this is somehow how we are taught math. We are learning about the theory, we're learning about the algebra and the geometry, but then whenever we are ready to use it, it's basically already a stage where most of the people dropped. And this is where AI comes in and say basically start using it even with small and easy and simple interfaces, and you will understand the theory underlying in later steps. So don't be afraid, go and try it.
So Eleni, let me stop you there. This is so important. This is so important. So it's not true that you need to have those amazing skills, experience, tools. Everybody can really do it. Well, you know, you're Greek, and I'm also from the south of Italy, Greek colony of Croton, land of Pythagoras. So we do not have to be Pythagoras. We do not have to be Pythagoras to do that. That's correct. We don't have to be Pythagoras.
That's
good to know.
That's correct. And you will see at the demo that Gabrielle will show you really how easy, at least to start, is. And then the more ideas you have, the more you want to explore some of the underlying things. These are available, and there are millions of available resources to look after. So what it means to build and design a model, and what this would like if you wanted to start. First things first, before you even start thinking about intelligence, you need the data to extract the intelligence from. So the first thing that you need to do is to collect the data from the different sources that you might have. This might be a Twitter feed if you want to do some sentiment analysis. It might be IoT sensors if you want to define actions upon the outliers when a device is getting too hot or so on. It might be sales data, etc. After you ingest this data in a storage system, you need to transform it to something that your algorithms will understand. You might need to reshape some of the pictures if it's pictures. You might need to anonymize some personal data or change the format to be more easily analyzed. So from CSV, you might need to do it to Parquet or some other formats. And basically, before you start training, being here at the third part, the data ready for use, training dataset, you split your dataset in the training dataset and in the testing dataset. So basically, you're going to use some of the data, a portion of this data to train the model, and then you're going to test how this performed. And Gabrielle, you want to mention the model development on the upside of the things?
So when basically NNA has created a dataset that I would like to use, I can start working on the data. She made it available for me to use in a format that my service, my machine learning service, will be able to digest or to ingest. Here, I would like to actually get a better understanding. What features would I like to bring in? So a feature is something like, if, for example, I have data that has age or name or land, Like that's a feature. So we have multiple features, right? And some features are more important than others. And maybe I would like to focus, for example, on animals rather than on, say, plants. So maybe I'll remove some of the columns regarding plants. But I could also add additional data to it, right? It's not only that I have to use one type of data. I could also use additional data to it, such as photos. I would train my model then, and then I'm actually testing with the test data set that Eleni also provided, whether my model is actually able to say this is the outcome and it's the correct outcome. And then when I'm actually satisfied with it, I'm actually saying, hey, you know, I would like others to also be able to use this. How can I do this? Well, this is actually where I would publish my model. So for example, on a website or in an app. And then lastly, this is also something that I would like to monitor, because sometimes, you know, a model can change over time because the data changes over time. Then I would like to know that for sure, and I would like to maybe retrain my model. Okay, Eleni, up to you.
So we begin with the data. Why data is so important, and why is the previous slide we mentioned that the data is the first thing to start with. It's really, really impressive in this table to observe the time when the biggest breakthroughs in AI happened. When, for example, Deep Blue defeated Garry Kasparov in chess, when Google managed to translate Arabic to English and Chinese to English. And you will notice that although the algorithms to do so were available in the 80s, the breakthrough happened basically when the data set, the right data set, were first made available. So it's really, really important and a priority for the data scientists to create robust and rich data sets.
So in this case, Eleni, it was not only because of the processing power that from one year to the other, well, because the first time we all remember Kasparov bet Deep Blue, but then on the second attempt, they could, because there was processing power, but there was a lot, much more data available to put into it, right?
Correct. Of course, the compute power also increases, and we see advance in this topic as well. But the most important thing, and you see here, even in the latest years, where the compute power is not so different. So from 2011, 2014, and 2015, the compute power doesn't change so much, but basically the data sets become available and publicly available, open sourced, and available to use from everyone.
Great, thank you.
What do we mean by data? First, we separate them in 4 categories: the numerical, categorical, time series, and text. In the numerical data, it's where the data points are exact numbers, and we split them basically in discrete values. For example, the count of properties, residential properties in Paris, or continuous values, continuous data, like the weight of an Amazon package that is delivered. Then we have the categorical data, which basically represents different characteristics. This is a basketball player's position, for example, in the game, his team, his hometown, or a movie genre, and so on. Then in the time series data, it's basically a sequence of number that is collected over a period of time. In finance, this might be the value of a stock, right? In IoT, in Internet of Things, this might be the temperature of a device. And then finally, we have text. And text is basically just words. Okay. Now you might notice that in these 4 categories that I'm claiming these are and nothing else, we might miss something. And what about the images, right? What about videos? What about sound recordings? Now, all these types of data are handled as numerical data. Pictures, for example, are handled as matrices, with each pixel representing a value of the color. Like you have the RGB channels, red, green, blue, and each color, each pixel has one value for these 3 channels. Now, how we are working with this data. And Gabrielle mentioned earlier that you might need to combine this data, right? So what types of data you would use in order to do a forecast in your sales? Think about it a little bit. You would definitely need to take into consideration the historical sales, right? So how we were performing in the previous quarters. This is the time series data. You might also want to see the text from the tweets in order to do some sentiment analysis and see how your users are interacting with your services, how satisfied they are. You might also want to use external data that is available from competitors in order to do a fair analysis. On the same page, in order, for example, in an image processing application, in order to identify a football, for example, you might want to use data that is related to its dimensions, its shape, its weight, and so on, but also images that shows the football on a professional game or in a neighborhood, for example, where children are playing. So combination of different sources of data is important in order to make the AI system as robust as possible. And now that we've identified the data that is coming, which is one side of the AI model, up to Gabrielle to speak about the types of different machine learning algorithms.
Yes, so thank you. So when we're talking about models, we also have some flavors available. And generally, we have 4 types of flavors that we see happening a lot. So first, with something that is called classification. Is this a cat or is this not a cat? Regression. How likely is it that my cat will sleep during the day? And then something as forecasting, as what Eleni also was mentioning, regarding sales data or finance data. Will my cat eat the food, yes or no, during the day? And it will look at all the data that I previously looked into from, let's say, a week or 2 weeks. And then lastly, in the detection. And this is something that you will see, especially in computer vision. Is there a cat in the photo or in the video, yes or no? Okay, let's go to the next slide. Okay, so for this, we're actually going to do a small demo. What the idea is behind it, please go to menti.com and use the code as indicated on the screen. What we will do is I will show you a small example of a computer vision algorithm. And I will showcase that with a few pictures that I trained it on for people to recognize whether they have a mask on or not. And for this, if everybody has the code, so repeating the code for this, 15433, we'll go to the demo and I will take over the screen. All right. So the question that we have for the demo, the first question that we have for this quiz. This model is trained on a classifier. Would it recognize an unfamiliar object? I'm actually going to share my screen right now. And we'll go to the algorithm. So I will tell you a little bit about what I'm doing over here. Everybody able to see my screen? Eleni, could you?
Yes, we can.
Yes, perfect.
Yes.
Okay, so this is something that is called custom vision. Custom vision is one of our services that allows you to train a computer vision model without actually having to code yourself. Obviously, it's also possible to code, but for this, you can also use the user interface. And here, actually, I have an algorithm that has quite some, or actually a model that I'm going to train with an algorithm with quite some pictures in there. So I have pictures here with people that have masks on. I have people in there that don't have any masks on. There are different types of people also in the picture. So we have old people, we have young people, we have male, we have female. So you see there's a wide range of different types of people in these pictures. And I trained the model, and we're actually going to go and start with the question. So here, please pay attention. There were 4 options, and we're actually now going to test whether your answer is correct or incorrect. And for this, we're going to take a picture of a duck. And it will tell me mask 1.3, no mask 0%. So why is this, right? You would ask. Why would it actually indicate that it also has a mask? Well, for starters, I used a classification model in here. So really the kind of question that will ask me how big of a chance, or no, how to say it like this, is it either category 1, like the mask, or category 2, no mask? And actually, we didn't train anything on a duck, so it wouldn't actually recognize this as such in a different type of category, because it doesn't have any tag with there that indicates a duck. All right, let's go to the second one. Again, going to take a picture. The question in here, and I will quickly give it over to Eleni. Could you do the second question?
Sure. You see already that we had some answers. Not too many, though. I strongly encourage you guys to go and vote for it. We might change the weight in these answers. So in the first question, people answered that it would not recognize the unfamiliar object, which is the duck in this case. The second question, Gabrielle.
Yes, will it count how many masks there are in the photo? So the first answer would be it will count the amount of masks in the picture. The second one, it will only show where the masks are in the picture. For counting, you need an additional algorithm. Then the third, it will count the people with and without masks. And fourth, it will show where people are in the picture without the masks. So.
It's coming up.
It's coming up, indeed.
It's coming up. We have a few of them already. There are difficult questions that we are making to this algorithm.
Yes, we told you this would be something that we will start very easy and then we'll continue to the very deep technical.
Eleni started, this is so simple, this is so easy, everybody can become programming, everybody can do that, everybody can be an AI and data specialist. They do that, and then there's always a little thing there. So we're coming up with a few answers there.
Look at that.
Okay, we have a bit of a shy audience, but the winner is...
Yeah, bum, bum, bum. I will share my screen and I will explain what the right answer is.
Oh.
We
have a 0 there. We don't want to make sure that's that one.
So in here, I actually put a picture with 2 people wearing a mask. And it will tell me whether there are people with a mask or without a mask. And it will tell me that there are actually people in there with a mask. However, it won't tell me how many people are wearing a mask. And that makes it very difficult. For this, actually, you would need to have a second algorithm to be able to do so. So what you would do then is first you would classify whether the mask is in the picture, and then you would do a counting task. All right, thank you very much for answering these questions. So a little bit about that, right? If we see kind of answers going, in a direction that we were thinking, it's not actually showcasing everything that I would like to do. You can actually say that you would like to add additional images, even though we can already see from this that actually this model was able to get a good classification out there on a minimal amount of pictures. So here I used 46 and here I used 75, where, as you can imagine, for the people that do a little bit more of these type of tasks, this is an imbalanced data set. And what it means is that there's not an equal amount of pictures in the mask and in a no mask classification for the tagging. Okay. All right. We can go to the next slide.
So far we had a lot of data out there. We train now to recognize, and then it's giving us already the analysis.
Yes, and luckily a lot of people were able to uncover what is necessary, right? It only will show where the masks are in the picture. For counting, you need an additional algorithm. So everybody who had the correct answer, way to go. Thank you so much.
Good job.
Okay. So let's see now about the bias and how we can bypass them. Gabrielle mentioned in the beginning some ugly examples of AI that were running with bias. I want you to think about, now that you have an overview of the data flow and the model flow and more information about the data and the algorithm, how did we end up on this? What we didn't take into account and which stages of the model development went not so right. Most of these bias are expected to be seen mostly in the dataset. So imagine you have a dataset of employees that include people that does not include people of minorities, and then a new hire, a new candidate comes in, and you want to classify basically how possible it is to hire them or not. If your previous data set does not include people of minorities, then the possibility will be lower, of course. Similarly, and a bit more sensitive topic, are systems like Compass. If you Google it, you will see that it's a system that allows and enables judges in US basically to predict the sentence and the length of a sentence for a criminal. And it's using again face recognition and additional data. Now you might understand how this is going basically, but people of color were more possible to be sentenced to longer time. So how we can avoid this bias and how we can that are introduced already in the data. One way that we see on the left of the slide is basically to expand and augment the data. So instead of feeding the data just with the original raw data, we can create extra data points that neighbor with the underrepresented cases. So for example, you are in a bank and you are deciding whether to give a loan or not based on the neighborhood that the person is living. Now, if historically the bank hasn't provided loans to these neighborhoods, these will be even less possible to give. But if you create a data set, data that is close to the underrepresented minorities, then you make it a more fair data set and a more fair estimate for the case. The other thing is that you maybe want to flip to change basically the pictures in order to represent different sides of the picture. So you might want to flip it, change the color, and so on in order to create additional data points and make the system more robust. This is for the images. Now, what happens with text? The processing of text is falling basically under the category of natural language processing. You might have heard it like NLP, where basically large sets of text are fed into the model and the words are represented as vectors. Now, those vectors are displayed in a two-axis system to show the relation between the words. In the case of the example in the GIF here, basically we try to project the woman vector in the direction of the king and the man. And what we are expecting basically to get is the word queen, even though the word queen has not been directly fed into the system. Now, the interesting thing happens when you want to project, when you want to identify occupations. So I want you to solve the equation that I'm going to say now. Woman plus doctor minus man. I hope that you all see that the answer should be doctor. Instead, the model that has been trained with the data across all over the internet basically identifies this equation as nurse. Now, this is expected where the gender stereotypes, this is where the gender stereotype really strikes.
This is so important. This is really important when looking at this and when programming it. Absolutely. Also because one of the key features of this year's Signature Award that we're giving for Microsoft is to the company and to the team members that features strong gender diversity also in their companies and demonstrate the best forward-looking technology-driven concept. So applying those concepts is a must.
And why is so important, Salvatore, for people from different disciplines to basically influence and have a voice over this model? It's normal. We are all people. We are all humans to make to apply our bias in the work that we do. But having a diverse team where people are encouraged to speak up can help us identify these unfairness in the model and basically manage to debias. And indeed, in this type of algorithms, you can have the debiased option and basically either penalize some of these assumptions or create a more diverse data set.
Indeed. Thank you, Eleni, for bringing it up. Because sometimes there is a lot of work, there is a lot of change that need to happen to do that. And we were very happy to embrace that with you.
And now over to Gabrielle to explain basically this heated debate that is happening now in the data science world.
Yes. So Eleni gave you kind of a background of bias in a data set, in an algorithm, and a few people, or actually a lot of people, have been thinking about how to surpass this in text, so in word embeddings, in the scenario that you just saw. And there are actually two options in general, starting with one. It's the general notion of how a child learns. When a child learns basically the concepts around him or her, it will start with very simple complex. And then when that child masters these kind of concepts, you will go to a next level. So, for example, it first learns that a ball is a ball, right? You can play with it, it's round, you know, it can have funny colors, but nothing else. And then secondly, if they understand that that is a ball, they might say this is actually a football. And it is being used with the feet, not necessarily with the hands. but it has some additional concepts around it until it completely masters what a ball can mean, so that you have different types of balls for different types of sports, etc. This is one way that we could also use for basically learn our algorithms how to learn the concepts that they need to understand in order to have not this bias in them. The second option actually is feeding it so much information that it will get so many concepts and will learn from there. So now we're actually getting to this really difficult debate within the data science community, or in the world of AI, where a lot of great minds such as Gary Marcus or Jan LeCun are talking about. It's the type of topic, what do we have to do in order for AI to learn, understand language the way humans do, without this specific type of bias in there? And this is also an interesting question, because that comes to another thing. A lot of people are thinking that for data science, you only need to have the background of a computer science major or a great math background. But actually, if we're talking about creating algorithms that are really smart, we need to have a diverse set of people in there. So people that have very deep expertise in a certain topic that is not necessarily data science. That can be something in economics, that can be something in finance, because they do understand what it means to have, for example, a machine that will break down in a week or not. Because that person knows that because of the sound or the looks of the machine, or the data that is attached to it, basically by stating that it will take half an hour longer to produce something than normally it does. And this is also something that we want to give you. If you want to be good in AI, make sure that your team is diverse. You don't necessarily have to have all those great math minds. You also actually have to have those people that studied anthropology, economics, physics, because they can give you an opinion, a background of their expertise that you otherwise may overlook. So, Salvatore, up to you. Oh, you're on mute.
There you are. There you are.
Yes.
Well, first of all, thank you so much. Thank you so much. I mean, this has been so informative. I know that some of the companies, the startups that have been presented and will be, they're already announced on our website and will compete next week for the European Enterprise Challenge, are applying some of those concepts. So definitely it's been a useful refresh for those who are already applying it. It has been an upskilling for those who are new to this and see how we can really embrace it. We had few questions out there that one of those is, do you use a particular programming language to create an AI algorithm? I don't know if any of the two wants to answer to that question.
Sure. I can tell you mine. Obviously, there's a wide variety in there in terms of languages, but I think one of the languages that is becoming and is actually very popular is Python. So you can do actually a lot with Python. So if you're able to write in code with Python, then most of the popular libraries are available to you. Also, I see R happening still quite a lot in specific industries. Think about finance. But then there's also another interesting scenario, because what we see right now is that for AI or for training a machine learning model, you don't always necessarily need to use a code-based approach, where you can also use, for example, automated ML or something such as what we call the designer. It allows you to kind of bring on those modules without actually having to code. So this is also something to keep in mind. Are you not that good in code? There's still a lot of options for you available.
Those sound great. And I love those scientific debates and questions, because there is another one which says, when it comes to important drivers of metrics, such as which factor affect sales or forecasting, and not just about image recognition, NLP, sound recognition as we saw it, how AI is better than statistical regression? They're trying to challenge you on that. Why? I mean, maybe on face recognition, sounds, and so on, sound recognition, yes. But how can we explain that AI is better than statistical regressions when it comes to factor related, for instance, that affect sales of a product? Eleni or Gabrielle, who of you wants to go next?
Up to you, Eleni.
We're seeing there, huh? We're challenging it. We're challenging here.
So the foundation is more or less the same, right? A lot of AI models are based on statistical models, and basically in many cases, also in Microsoft, we've seen that in some cases you just need, for example, queries, SQL queries, in order to identify how the sales will move. So I'd say that the one is not contradictory to the other. You might use both for different use cases.
It might be also related to the speed of it. I mean, yes, you can create some model of statistical regression, but in reality, I mean, can you bring this up to date continuously, especially when we also relate it to sales, that we need to move very, very fast, because if we're not getting there, our competitors are getting there. So with the help of AI, probably this is also something that will push us forward and get there first.
Correct, and the way that you are consuming the model basically depends also on the use case. So if you need real-time response, then you would already have trained the model, the AI model, and just input the new data that is, for example, for the stock value to consume it faster.
That's good. Good to know. So someone can conclude that the bigger the data set, the smarter, the more accurate AI will be. Yes, I mean, I think we all agree about that, right? I mean, the more information, the more data we have it, the better, the more accurate will be. Anyone disagree with that?
Well, I think it kind of, if leveraging back a little bit to what we discussed in the absolute end, I think this is the current debate, right? If we're looking into basically the champs in AI, this is the actual question. Do we always need to consume more and more and more in order to get a better outcome, or do we have to use the data in a smarter way to train the algorithm? I think in generally what we as people outside that very ivory tower of academia will experience is that it does need a lot of data. But there is a turning point where I think the debate is actually at the moment.
Sounds great. Well, I don't think we have some other questions out there, or at least I cannot see it from here, but I wanted just to flag a couple of things for next week. So we have 18 of the best startups that have been selected out of 17,000 individuals who created together with their peers, they put into action their entrepreneurial idea. Where you can find it, you can all find it on the website of the competition, where also these webinars will be hosted. So for those who wants to see particular slides of what Gabrielle and Eleni have just shown us, you can go back and forward and go deeper into that one. Any final remark, Gabrielle and Eleni?
I would say everybody, the best of luck, may the best win, But still continue if you like. If you believe that you have a solution that can create a better world, the greater good. Also, I think for the 18 finalists that are there, you're there for a reason, right? As Salvatore already mentioned, there were so many people that applied, and you're there, so that says enough. So for next week, all the luck, and congratulations on being one of the finalists.
Eleni.
Best of luck from my side as well. Reach out to our emails or on LinkedIn. We will be happy to connect and discuss any further questions you might have.
Well, we talked about Greece. We know that we are all going to be there virtually next week. Let me thank really the Microsoft as the great partners, that has accompanied us, been a fantastic travel companion in all these past months in putting together the event. Thank you so much to all of your team, to all the tools that you have provided us to innovate in this space. And let me thank the JA Greece team and the JA Europe team who have been working with all of you on making this as a successful webinar. As said, we still so much thrilled. It's gonna take few days, maybe next week at this time, more or less, we are gonna have the great announcement on not only on the best startup of the EEC 2020, but also of the Signature Award of Microsoft. Again, thank you so much for your attention. It has been an absolute pleasure. Cortana, now you can switch. Bye, everyone.
Goodbye.